Howdy, guys. Looks like the microphone's working. Welcome back. Hey, we're going to make a mini PCB today. So at work, I'm doing developmental testing on a board I designed, and the board has an input for an ID resistor. So it's going to check an attachment that has an ID resistor. And there's 6 options. And then it has a temperature sensor, like on the 3D printer where you're sensing the temperature of the bed. So it has actually a couple temperature sensor inputs, and the thermistor on the temperature sensor has a known profile. So I made up some mini PCBs with the little 2 parts in parallel, where I put surface mount resistors, and then I had wires and a little connector on the end of each one, so I could just go up to the connectors and plug and unplug, right, and look at the voltages on the multimeter and see if it's behaving the way I expect it to. And I just have a feeling that my cable harness, like it would be a lot faster to have a rotary switch. This is a 3-pole, 12 position, 12 throw, or yeah, 12. And it would be a lot faster to have this guy on a PCB, all the resistors on a PCB, and then like a probe interface. So probably just the solder wires, and you could solder wires to it and then have a connector over there. So yeah, that'll be it. Just 2 solder points, and that's it. It's not a variable resistance box. It's a selected resistance box. So you would solder onto the mini PCB the resistors that you want in each given position, and then it'd be your selector box for that board. And it would basically save a couple hours in prep time, making your little custom harness. And, you know, this should be a lot faster, boom, 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 than, 6 or 12 little board with wires with connector. So, yeah, should save some time and also be more tidy, organized. And then you see where I'm going, right? This is a mechanical switch, but you could have relays and have a microcontroller, and then yeah, just even go ahead and do the your own multimeter, right? You could build we could build an open source automated test fixture. But anyways, we're getting a couple years ahead of ourselves right now. Today we're going to make a mini PCB with this guy, and it's going to select between different resistors, right? And if we can't succeed at that, if we can't do that efficiently, effectively, and enjoy doing it, and release something this simple into the world, if I can't do that, then what makes me think I can go on and build this whole open source automated test equipment thing? If I can't do a single little board to hold this guy, right? So that's what we're going to do today. And the timers started. We're not even 5 minutes in to the project, and we've already got a pretty clear idea of who the customer is, what they care about, the technology landscape associated with the tool, and kind of a roadmap for how this is going to fit into the bigger picture of multiple years of creating value as an engineer. So all that to say, let's zoom down and display capture. Yep, cool. And then, yeah, I was watching Sam Harris. Okay, that's the display. Okay, there we go. All right, so I muted the desktop. Okay, cool. So we go to Eagle. Again, one of the things I've said, if I've said it once, I've said it at least 3 times. One of the things I like about Eagle since Autodesk took over is they made it such that the navigation pane also displays Microsoft Office documents, so Excel, PowerPoint, Word, also PDFs. So I set up the miniPCB repository such that the Eagle one, at least, there is no other one, such that you can use it to navigate the whole developmental file repository. So anyways, okay, ECO form. This is going to be 1021. Yeah, something has been making me sneeze. I think it's all the cats running around. We need to give it a part number. Sorry. Nolan, we just did this 3 times this week. You should be good at it by now. I know. This is why I write everything down. Since this is more a multiplex board than a probe board, we'll put it down at 120. Wow, I should probably put it down at 120. I'm not sure if I'm going to use this revision indicator thing here. Or this package thing. Description. Selector. Multiplexer. There, that's good. So it'll be the multiplex switch 0805 components. And we'll change this to in process. Oh, sorry, y'all probably couldn't see that. We'll say, do that, and then we'll go back to here and we'll copy this. Copy. We'll come over to 00A, select this project, say new project, 00A 120. Edit description, paste. Okay. And then I need to go to the engineering change order, 00A 120. Oh, come on. Barely fit, doesn't it? Requested by me today. Drawing number. Revision A. Maybe I should come back and spell out the actual, like, what's being released. It'd be a good activity for the final step, right? Justification of change. Product development. There's no image yet. Save and close. All right. I want to copy from the one I just did. So this guy. So copy. $120. Let's go into here. Attribute. Change the part number. 120. Okay. This attribute. Circuit name. Paste. Multiplex. Or that was the title. Let's see. One pole 12 throw. It's today. It's the third here. Okay, multiplex switch, 0805 components, probe and prototyping, manual switch, one pole 12 throw, hookup wire. Okay. Save, delete those guys. Delete group. Save. Okay. The mirror. Move. This is a stimulus only. So that needs to, here, properties. This is miniPCB 0 pin 50 by 50. I knew that. I just delaying doing the work. That's not how the work gets done, Nolan. I know. 0 pin 50 by 50. But it's really the schematic image that I want to edit. I want to want to have one that's just like an inputs only or an outputs only or a label. Can I make an attribute and then say name 1, name 2? Okay. Copy. Okay. New symbol. We'll make this a 4-inch. Properties. Length is 3 inches, so I want to cancel. Give me a 1-inch grid. Let me move this right here. There. Move this. Okay. So hopefully that's enough, right? And then I need to name 1. Like that. Save. Now, I need to go up to device. Say miniPCB 0 pin. I need to add a symbol. miniPCB 1 line 4-inch. Right, just find a spot. Okay, cool. Now I need to add name 1 as an attribute. And while I'm here, I'm going to put name 2 in case I ever do a dual. Do I have to add it to? Oh, fuck. I have to add it to each one, don't I? Unless there's a way that you can do that. Anyways, is there a way? Will this work? No. Nope. Nope. Fine, we'll just make sure it's on the one we care about. That one, right? Name 1. Cool. It's got it. Should we save? Okay, we can close that. Come back to here. Well, say library, update all, invoke 1 line 4-inch. Okay, now I can delete that one. And let's see if the name 1 works. Name 1, and this is there it is. And we can hit mirror and drag this over here. Make sure we can see that. Good. 4 may have been too long, but 4 probably was too long. We should do a 3. So we need to go all the way back into the library and find the part. Make a 3. Copy. Okay. Okay. We also need to look at that rotary encoder, but we can start putting stuff on it though. Pins 1. This guy. 1 there. 1 there. Um, okay. That's 12. Okay. And then the rotary encoder, I need to go and edit that symbol. I don't know if this is consistent with the IEEE standard. We should add it on pin 1. Some fighter jets going past outside. That's not normal. Something military-wise is about to happen. When 9/11 happened, we knew right away. There were all these planes. Okay, so we're going to ignore B and C and just have A. So B and C are here, but they should be treated as a no connect. So to do that, we will I'll just leave them alone, but B and C no connect. So okay, so and then the whole space is just an A connection space. So I'm gonna say, and then copy. This font was too big, wasn't it? Size. .1. It's probably fine. God damn it. It's going to be a long list. Text. Four, 4, 4, and 4, and 5, and 5. Okay. I feel like that's too big, though. Here, we'll change the fonts to, sure. Wait, come back here. Yeah, we'll do that. Good enough. Okay. These guys. I don't know. Was I doing this? Save. Go back to here. Add part. Oh, I need to connect this guy to that one. I did copy this, right? I didn't just delete all the other ones, right? God damn it. Ah, God damn it. God damn it. I'm basically deleted my other one. God damn it. Well, at least I know my pinout is correct, so close that. Sorry about that. One more click, that's it. Yeah, okay, cool. Sure, it's fine. Okay, like that. So now, Control W. So we have A, and then these, Control W. These just trace out. Control W. Hmm. Okay. Give me the no connect. Okay. Then all these guys come back to that same spot right there. So we're going to go Control W. We'll see if Eagle works. Yeah, cool. Okay. Now let's see if I can do this like in the other one. Oh, wow. Really? Uh, well, it was the thought that counts, huh? Okay, we'll do it the long way. We'll do it 2 clicks off just because it's a long resistor chain. Okay. That should be good. So now you'll be able to put 12 0805 components. If you don't put a component, it'll just be an open. And yeah. Okay, so let's go into the footprint, edit footprint. So this part right here has this alignment dot right there. It's in the wrong side. Oh. It's on the wrong side. How did previous Nolan get that so wrong? Ah. So if it's down there, which one would that be? Then you rotate it all the way that side, and you point this guy at the dot. Does it go on the dot? It does not quite. Go on the dot. It's not perfect. So, but that is kind of position 1. And then they sweep through 30-degree angles. It just off to the side. Like that. Well. Control Z. We will put this guy down there. And then up here, can I put something and then rotate it? How do I do that? It's for the, oh, no. We'll put this underneath. Put this on a metric grid. think I can put the dot on the inside, right? Okay, and then how can I get text to be in there? Is that a feature? Pattern. Item count 12. 12. Circular. Spacing in degrees 30. Okay. Oh, maybe I have to place a object. For position, we'll say P, and we'll say center align, and this is at the top dead center. We'll go down to a 0.5 millimeter grid. This is at 0 right there. Place it, but then we want to go in and change its size to 2 millimeters vector. Okay. 12. Okay. And then now I want to rotate this guy. 12, 30, rotate item. I have no idea what's going on there. So if I select this guy, now say pattern, item count, circular, 30 degrees, rotate item. Do I have to paste it 12 times? Right? Like, hmm. Sure. We'll just do it the old-fashioned way. That looks about halfway in between. Wow, pretty good, huh? That one's off. Okay. Um, I'm gonna make the font smaller. Oh, that's way too small. Okay, we'll delete the outer ring, and we will move that out. Move that out. Sure, we'll do it like that. And let me guess, is this pin 1? That's B. That's A. Well, that'll be fine. Okay. Yeesh. No, I'm just messing up your other boards, huh? Okay. Switch to board. That's it, right? We're done. Now we get to do the fun part. Okay. Okay. This guy. Should I put it on the other side, or should I put them together where they can be heat shrunk together? I think I'm going to put them closer together. Not sure what I want to put on this other side. But this guy needs to be centered. Oh, no. Yeah. Okay. Resistor on the inside. Resistors on the bottom. Or on the top where you can access them. Yeah, it's like, do you want them visible where it's easy to swap them on and off when it's on your fixture, or do you want them a little bit protected? I think I want them visible. Let's try that. I don't know. Maybe. Wouldn't it be crazy if something did happen and the rest of the world was all reacting and I'm just sitting over here in my workshop like, yeah, so as I was saying, do they take away the unsmash? Restore position. There. Okay. So routed, this guy comes through here, and then these guys go up, over, and down, and they just fan out. All the tracing is on the top. Yeah, it should be fine. Ready to route it. So let's go into the route mode. Let's grab 2 millimeters. We'll put the 2 millimeter. Then we'll go down to 1 millimeter. And we will come across and up to there. And then we'll come like that. Kind of tragic. Maybe. Or maybe not. This should be pulled back a little bit further. It's not that big a deal. The clearances are well within the voltage range of the switch. Okay. These guys don't have the text because it's the no text option. But property, this is P2, this is P1. So we'll put P1 on T place with 1.5, 12, like this, vector. That's not on grid. too close. Okay. Well, don't want it too close to that switch. So I can do that. There, we'll keep them a little further away from the switch. Now we'll put P1 and P2. P1, P2. And we will put a rectangle for you guys to write on. Down there. Yep, that's about it. Nice. I should get my multimeter and double check this pin out. Okay, so just because it's a whole $5, and it's the embarrassment really of getting it right the first time and double checking previous Nolan. Okay, so so that's there. So this one is A, and P1 says that R1 needs to be connected to A. So I'm in P1 right now, and then so I should see a connection to this guy right here. I'll turn the buzzer on so y'all can hear. Okay, let's see. Hang on. Am I right? Right. Right. Okay. Now, so I'm in P1. 1, 2, 3, 4, 5. Right. Okay. So now I expect A to be connected to R5, which is that guy. So if I'm looking at it like this, it's this one. Wait, what? Did I get off A? Okay. So A. Oh, hang on. It's labeled. That's A1. Okay. 1, 2, 3, 4, 5. It should be A5. No, it's not. It's on 2. Okay. All right. Go back to the starting point. Might as well get this right. A1. Okay. First click. A2. Anything else on A? Should be no, right? No. Okay, just A2. Third click. A3. Yes. Fourth click. A4. Yes. Fifth click. This should be A5. It is not. It's A1. Okay, so sixth click is A2. So A just A3, A4, back to A1. So A only goes to 1, 2, 3, 4. Well, that's too bad. So I can create a 4 position, kind of like what I had initially. Nolan. I messed it all up, didn't I? I wonder, is there a way to... No, because I don't want to undo my schematic symbol changes. I'll just recapture the... So, P1, A connects, this guy connects to that guy, and it goes 1, 2, 3, 4. After that, A goes right back to 1, 2, 3, 4 again, like that. So A never touches these other ones. Well, So, maybe I should connect all 3 of these together, and then you can parallel, right? So you can have, no, that's just way too complicated. Just strip everything off except the 4, simplify the pin map, and it's a 4 selector. Oh my goodness. Okay. Delete. Wow. Well, it was the thought that counts, right? Component selection. It's important. Edit. We will mess it up yet again because the other one was not correct. So, cancel. Switch. Edit symbol. Save. Okay. You'll need to limit the library update all. Nice. Now we can bring this up to be a straight line. Wow. Cool. We can fan this out a little bit more. Now that we got the space. Okay. Save. Well, it's not a 12th row. It's a 1 pole 4th row. Not add part. Cancel. Attribute. Attribute. 1 pole 4th row. Okay. There it is. Save. Maybe I should be like UL 1213 style wire instead of hookup wire. Yeah, I think I'm going to start doing that because hookup wires. Okay. Save. Okay. Now switch to board. All the stuff's gone. Stuff that we didn't need. And this guy. Should I leave everything or create space? Leave both wires over there or slide one over there and put the I think I'm going to move it so that it's symmetrical this way. Okay, so that is 2, 4, 5 from the edge. That's 2, 4, 5, right? 2, 4, 5. 2, 4, 5. Move this guy. Oh my God. It's like that Shakira song. Give it up to me. And it's the wrong size, so we have to delete it anyways. Delete. Poof. Rip up. Control W. Like that. Move. Like that. I don't know. Maybe. Leave it alone. It'll be fine. That. Just need to run the analyze. Analyze. Execute. Oh, wait a minute. I forgot to draw my rectangle. What? There you go. Save. Okay. Export part images. Jump over to the schematic. Export schematic image. Close this. Close this. Yes. Script from 95. Control A, Control C, close. New script. $120, all occurrences. Close. New. Board. Script. Browse. Eagle. miniPCB. 00A-120. Script. Oops. Oh man, I forgot to save it. I knew I was forgetting something. Dash A. Now run the script again. A-120. We'll have to say yes. Looks good. Looks good. Yeah, that should look good. Okay. Save. We'll generate the Gerbers. And then we'll actually do an order because we'll have enough Gerbers to do an order. Oh, sorry. Eagle, cam, Gerber 2-layer. Process job. Select. Yes. Okay. So yeah, we will well, good thing I checked, right? Otherwise we would have had a bunch of junk made. So it's a 4 position. That's why you double check. Saved all of $5, but more important than that, I saved the disappointment, right? Like, okay. Open. Eagle. Cam. Exelon. Process. Select. Yes. Yes. Open. Delete. Date modified. DRD to this one. compressed zip file. Select them again. Thought I clicked off. Delete. Okay, so that's it. Well, datasheet. So now we go back to Eagle. Cancel. Save and close. Okay, so now we go back to Eagle and we go to templates, datasheet. Okay, here we go. What did I call it? So if I pull this guy up, multiplex switch. Okay, part number with the revision. Check 21. Okay, close. Part number 00A-120. Manual switch 1P 4th row. Am I uppercasing these or proper casing? Here, let me look. What did I do yesterday? Or the day before? Proper casing. Variant description. UL 1213 style wire. Oh, cancel. Let's see. Well, actually, I do have to save it. I do have to save it. More. Browse. Well, here, A-120, 00A-120. Stuff shifted, didn't it? What's going on? Time to run the macro. So, like always, we'll zoom out so we can watch. We have to move files to this folder so that it doesn't crash. Date modified, it's the September ones. Copy 120 and paste. Okay, and developer, macros, run. There they go. Saving us a little bit of time. We don't have to go and click, clickety, click. Boom. Congratulations, the images were inserted successfully. And then this guy. Right here. Picture format. Horizontal. There we go. Looks nice. Schematic. Okay, now we need to move the parts list form above. We can get rid of this. There's really no theory of operation. Okay, so this cut can go right here. Then all this gets deleted. Delete. Okay, there we go. This is 1021. It's not official yet. Okay. Save file. Save as PDF. Bookmarks and headings is enabled. Save. Okay. I think we did it, guys. I think we're ready to order. Save. Close. 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 Clean, right? Okay. Let's do the GitHub commit. So I'll close Eagle. GitHub. GitHub desktop. Libraries. Oh, yeah, don't remind me. And today is the 3rd. Wow. 1/11 in 2021. Push. And the initial development took 1.5 hours. So how much do you think somebody like me should, benefit from 1.5 hours when that 1.5 hours is uniquely characteristic to my life? Being the stuff I do for fun. I don't know. I'm wondering. Something to think about. But, yeah. So, okay, so we got this board designed. We're ready to order the for the test setup stuff. This will help. This will help me my setup be a little nicer. Okay. All right. And then I'm gonna go over to Mouser and buy some parts because I got the shipping notification that the 4 mini PCBs we ordered a month ago or something like that before the new year, but not soon enough before the new year. They shipped last night, so we'll get them. We'll get them probably on Tuesday or Wednesday. And so if I order the mouse, so today's Friday, so if I order the Mouser parts this weekend, they'll ship on Monday, and I'll get them on Tuesday. So then we could be soldering up some mini PCBs and bringing them to life in the next week, well before next Friday. Wow, we could. These actually feel better about like something about when I got these, I got disappointed. It was like I just didn't want to solder them up, but these should be good. These should be good. And then I've got 4 more here that I can update, but there's probably going to be something on these that I want to tweak. So, Okay. All right. Well, hey, thanks for hanging out. We'll see y'all in another video. Later.